And next conservation law is baryon number, right? Okay, baryon number. So what are the baryons? See, the baryons are together spin 1 by 2, spin 3 by 2. These are the baryon numbers. So therefore, I am going to write that baryon number first. So baryon number baryon number, that is B. How this baryon number we are going to define? So what are the baryons? You know the spin 1 by 2 baryons, spin minus 3 by 2 the baryons are there. Okay, so those are the baryons, all normal baryons. So here also I'm going to write one word before going to the conservation law of baryon. Normal baryon such as the order P plus N naught sigma plus sigma minus sigma 0. This one cos I write 0 and the minus. These have a baryon number 1 plus 1. Baryon number is plus 1. Need to write this quotation mark. So remaining thing, definition baryon will be defined like this. Baryon number plus 1 is normal baryons minus anti-baryon number is Y monad G. Okay? Not G, Y baryon. 0 for other such as mesons and leptons. Okay, so then it's better to write here that baryons, okay, for taking very fastly to spin and our practice also 1 divided by 2 baryon. So these baryons En, this one sigma plus sigma 0 minus. Oh, benzene next. Okay, 0. Okay, we just adjust the pin the 3 by 2 baryon. Deltas. So you just write these things for that. So how I remember these things? So these three are the main classification. So from main classification, the order is the one. From that main classification, I remember main general classification is the right elementary particle classification. First, you need to remember that one. Then you can get all the. Just try to write that classification first, then you can arrange according to your memory. This zero, this complex, right? Complex minus 5. Okay, these are the variants. Now I'm going to check the same thing. If bar is present, that particles are the uh, anti-baryon number. Okay. Okay. First here I'm going to checking first in the reaction N tends to P plus E plus this one. Okay. So first we know already here. See, these are the variants actually. Variants, right? So why I am here is here I'm writing specifically. See, in case here uh, minus is there, right? Sigma minus. Then you can try to put the minus equation. So not like that. So you need to remember this. These are all variants. Number is plus one. Whether n naught is there, minus is there, not is there. So these are the normal variants. So these are all under comes to category of normal variants. Variant number is plus one. So therefore n and p are normal variants, right? P are normal variants. What about this E? Electron is baryon or not? Electron is not baryon, right? So these are the lightweight particle electrons. Electrons are baryon number is 0. Okay. So therefore, baryon number 1 is 1 1 tends to 1 plus 0 plus 0. So baryon number is conserved. This is the first example. Second example. For example, P plus P tends to A plus E plus is there. So baryon number one tends to K plus is ions, right? So ions are not the variance, are 0 plus sigma plus is there here. This is not conserved, which means the conservation of baryon is violating this rule. So like that, you need to check all the reactions. You need to remember this. So first, you need to remember this word all variants such as the P plus and not sigma and sigma plus sigma minus CSIR and omega also. Okay? So these are the key relations. So if you want to practice any equations, here I am going to give two examples. You need to check K minus P tends to 5 plus sigma plus 5 minus. And fourth one, for example, here P plus tends to N plus P plus 5. You need to check these two things. Okay, check these two things. So baryon number is conserved or not for practice. Next one is what is the conservation law in that order? Um, isospin, very important this one. Okay, you can finish isospin right now. Isospin. Next conservation law. Third conservation law. Isospin. So it is denoted by I. textbooks. The isospin exists only for hadrons. Okay. What are the hadrons? Mesons and baryons, right? Okay. Here the first point I'm going to write isospin. These are enough for competitive examination. Yes, if you want these classes, soon I'm going to start this physics classes. Then you can maybe in nuclear physics classes it will take long time. So first I'm going to complete quantum mechanics. Take almost 3 to 4 months to complete our entire syllabus of quantum mechanics, statistical and classical mechanics, mesons, variance, right? Isospin. What is isospin? So textbooks is there this word isospin. So after studying all these things and some materials, so it is simply like a multiplication, multiplication. So which means multi number of particles in the group, or I can say like this here, a number of particles in the group. So before checking isospin, we need to remember these two uh, bullet points. Okay, isospin exists only for hadrons. What are the hadrons? Mesons and baryons. So mesons you should remember, and baryons also you should remember. So this isospin I'm going to this multiplication is I'm going to write like this m m equal to 2I plus 1. You just remember the formula. Here m is stand for the multiplicity of the group. I is the isospin. Okay. The number of particles in the group. The m means the number of particles in a group. Okay. So here I'm going to discuss the first thing. Um, P and N. These are one group, right? Okay. So therefore, how many particles are there here? Two particles are there. I'm going to use this formula. Two particles equal to 2I plus 1. Then 2I equal to 1. I equal to 1 divided by 2. So therefore, proton isospin number is 1 divided by 2. Neutron isospin number is 1. Next category, first category, second category. So baryons are there, right? Okay. Sigma plus is safe. Sigma 0 is safe. Sigma minus is. In case if you try to observe classifications, why I am classified different type of manners in first way, because these are classifications are useful follow this conservation law easily. So here how many groups are there? Sorry, how many particles are there? Three particles. Three. So this is how we're going to simply calculate the spin number. Okay, isospin is equal to all these particles irrespective of the plus or E not or E minus. Yes, if you saw this E plus in the reaction, what is the isospin? I sorry 1. E naught is 1. E minus sorry uh, is sigma. Sigma minus is isospin is 1. Next. And in mesons, beta mesons is there. Only beta mesons are there. Group of particles is there. Groups are there. So see here the mesons. Just want to remember again it's mesons. Okay. Isospins are there. P is the lambda. Spin 1 by 2 baryons. Spin 1 by 2 baryons. No need to check these two things. So why I didn't check these two things? Already group of two particles are there. Isospin also 1 divided by 2. Okay. Lambda. So how many particles are there in this? I already show you that in that group. One particle is there, one single particle. 2i plus 1, the formula. ai is equal to 0. A single particle is there, that group of next 4. Delta plus is there. I mean baryon number spin 3 by 2 particles are there. So delta plus, delta 0, delta minus. So how many particles are there? 4 particles are there. 2i plus 1. Then 2i equal to 3. I equal to 3 divided by 2. So this is the isospin. Okay. So here I'm going to the particles group I is equal to 0. They note like points. Particle group. For example, I equal to 0. Then we can call this group singlet group. Example, natives, lambda native. Particles in a group, for example, I equal to 1 divided by 2. These are we can call doublets. Doublet. P N K plus K naught and so on, etc. Many particles. Doublet. Particles group, for example, I equal to 1. Then we can call this triplet groups. Triplet, not group. I don't know. They're saying these are the triplets. Okay, triplet group. Textbook say that. From the textbook, I understand like E plus, E minus, Sorry. All right. And this thing also plus or minus zero also this type of notation. Triplet plus zero minus. Okay, this is very very important. Need to remember. So particles in the I is equal to I equal 3 by 2. What we call? Just comment. Isospin is same for all particles in the group. Okay. One more note. You remember this one. Note here. Isospin. Isospin is same for all the particles. Well, I told you this, but you just try to remember. Okay. So this is all about isospin and variant.